So in an earlier video, I showed you how you could construct your own LED light source for your pumpkin. But why build it when you can hack it? So I have an outdoor solar light, and I'm going to attempt to modify it in such a manner that I can use it in a pumpkin illumination setup, such as what I have behind me. So I'll just modify the LED to a red LED and mount it on the back of the pumpkin and run some wires down to illuminate the pumpkin. So stay tuned for that. So I've opened up the solar light and the soldering is awful. You can see here that there's a tiny little blob of solder holding this wire in place. This is to the battery terminal, so that's a rather important solder joint. So there's going to be some parts that I'm going to have to touch up. But what I'm mainly going to focus on is the LED here. So this is the white LED. And it appears this is going to be the cathode and this is going to be the anode, so positive and negative. And the good thing about this is it's a white LED, so it's one of the highest voltages an LED would see. 3 volts approximately, and I intend to replace this with either a red, which is 1.8, or an orange, which is 2.1, I believe. So there's more than enough voltage to drive that. Now I may need to put a series resistor in with that LED just to limit the current so I don't burn out the LED, but we'll see if that's necessary in the end. Okay, so at this point I'm going to remove the white LED from the circuit so I can make some current measurements with the red LED. Okay, so that's 1. And that's 2. So the white LED is now completely out of the circuit. And I'm going to replace it with a red LED. Okay, so I've rotated the board. This is where the white LED was. Here are the leads from it. And I'm going to solder some wires in there to make some voltage measurements to ensure that the voltage and current are going to be suitable for a red LED. Okay, so those are nicely soldered in place, and I have the wires going down to a breadboard so I can analyze the voltages with varying loads. And if I place the battery in here and check my DMM to see what the voltage is, and here's the voltage output of those 2 wires, which is quite strange because it takes roughly 3 volts to power a white LED. So since it's below that potential, it makes me think that it's a pulsating DC signal. So I'm going to hook up my oscilloscope and analyze the voltage that way. So I've connected my oscilloscope to where the diode used to be, and if we look at it on the oscilloscope, this is at 1 volt per vertical division, and it reaches 2.5 volts, so that makes more sense with that potential there. So if it reaches that voltage, I'm probably going to need a resistor in there to limit the current for the red LED. So instead of worrying about all this voltage calculation, I'm just going to measure the current for the white LED and put a resistor in until it matches that current on the red LED. And just to illustrate how I'm going to measure the current through the white LED, I'm going to take the lead that I've soldered in place to the anode of the white LED, and then from the cathode I'm going to attach a wire to an amp meter, and from the other side of that amp meter I'm going to go back to the negative on the PCB. That way I can see what the current is running through the white LED, and that would be the ideal current to have running out of this circuit. And then I can just take my red LED and place it where the white one was. and then place a potentiometer in series with that LED. And adjust that value until the current on the amp meter measures the current that was through the white LED. And then once I've found a good spot, I'll just need to measure the resistance from here to here and then find a suitable resistor to replace the potentiometer. So here's the current running through the white LED. And now I just need to get a potentiometer and a red LED and match that current. Okay, so I have the potentiometer in the circuit. Now I'm just going to rotate the value down until I get to that 2.37 milliamp range. So that's pretty close right there. So now I need to measure that resistance. So that resistance is 120 ohms approximately. So I don't have a value of that resistance, but I do have a 150 ohm resistor, so that will be suitable. So let me just check the current using that resistor. And it is at 2 milliamps, and that's a fairly bright LED, as you can see, so that's a nice value. Alright, now let me just solder this all together. So prior to soldering the LED and resistor onto these wires, I'm going to need to run them through a hole here. So I'm going to remove the old LED. And I do want some strain relief here, so I'm going to get my hot glue gun and glue those in place. Alright, a little messy, but that should do it. And just to ensure the battery still fits in place, it does, good. Alright, now time to solder the resistor and LED to these. So I found the best way to mount the LED was coming in straight from the bottom, like so. And when it comes to mounting this, provided you have thin enough wires, you can reattach this, and you could drill a hole in the back of his head, like so, of the same diameter, so I'm going to go ahead and do that. So when you drill the hole, you probably want to go a little high on the back of his head, just so you get sunlight and so you don't see a hole when you view the front of the face. So go ahead and make this hole here at a nice steep angle. Okay, now just insert this, and there we go. So there you are, your first cybernetic pumpkin. And it does look pretty good at night. So thanks for watching, and I hope this was fun.